So, when you have a log and you are looking for this piece here, not the base and not the actual exponent, just put the base with the exponent and you have your x. Alright. Actually, there's really just one slide, but there's one problem that wouldn't fit on here. It's on the next slide. Okay, so. Yeah. Probably not. Yes, this is 3.4 part 2. 3.4 part 2. Okay. 49 we just did. 51. What's the base of 51? That's for log. That's right. E. Log has a natural base of 10. Natural log has a natural base of e. So x would equal e to the second. Punch it in your calculator. 53. X plus 5 would equal 4 cubed. Solve for x plus 5. X minus 4 equals negative 3 to the negative third. Solve for x. Solve for x. All of these are done the same way. Hold on. I heard a what first. Let's look at. Hold that thought for a second. Back to what you were saying. So, like this one. All of these, all we're doing, once you've isolated the log by itself, all you have to do is take the base, swing it over here underneath this number. So x minus 4 equals 3 to the negative 3. Then you would solve for x. Good. So all you'd have to do is add 4. 59. What's the only thing we have to do before we do that again? What's the only thing that's different about 59? Yeah, you have to isolate the log or natural log, so divide by 5. Well, let's see, 61, you have to subtract 6, then divide by 2 first, but after that it's the same. Yeah. This one, just swing over the e. So it'll be radical x plus 3 equals e to the first, square both sides, subtract 3, yada, yada, yada. So it'd be e squared minus 3. Yeah, it'd be e squared, e squared minus 3.
Yeah, I wasn't just making it up.
Well, this side's the same, except you have to put things together. Before we get to 67, is there any questions about any problem from the left side of this screen? 61, you need to switch colors. You subtract the 6, divide by the 2. Exactly. So x would be e to the negative 1/2. And you don't even have to punch. I mean, that's just going to be an ugly decimal. So if you want to just leave it like that, you can. That would be 1 over the square root of e, but I wouldn't even do that. I would just leave it as e to the negative 1/2 if I was you. Actually, I guess it says use a calculator to approximate the 2 decimal places. So you could just punch in e to the negative 1/2 in your calculator. What'd you say? Fourth, yes. You're right, e to the 4th. You're right. Yep. Rocking and a rolling. All right. Only thing different about the right-hand side, is you have to use that second log section we did to combine this into one logarithm. So like 67 is going to be log base 3 addition. Guys, what do we do with logs when we add them? I was asking them, but thank you. All right, so multiply these. I would recommend you just go ahead and FOIL them today. That's when you multiply them together. I've done a lot of foiling in my life. Yeah. So you swing the 3 over. I need a new slide. No, I don't. I'll just make room on this slide. So you swing the 3 over. That becomes x squared minus 2x minus 15 equals 3 squared. When there's addition, you multiply this times this. And I just went ahead and FOILed them. Yep. Yep. So that's 9, which you have to subtract over. Now this we just did yesterday during the review portion. How can I solve this now? If you could have factored out x, you could. But how do I solve this kind of function? Yeah, there you go, quadratic formula. And there are 2 x values for this one. And you'd have to do the quadratic formula to find them. Yeah. The second section of logarithms we did, remember, every time there was addition, we just put them together with multiplication. Every time there was subtraction, we divided. And then there was the power rule. And to answer your question, it became 3 squared. Well, to make it 1/9 quadratic, I just subtracted that 9 over. That's all I did. No, no problem. Yeah, you just do quadratic formula and it would give you your 2x values. Negative b plus 1. Yep, and you're done. You're solving for x on all of these. Oh, probably. Yes, x plus 4x minus 6 looks good. That one I guess you can factor, can't you? All right. This is actually the only slide. We will look at the potentially hardest ones. This should be the hardest one of the day. All right. This is the last one. Absolutely. Alan, you be thinking, because I'm going to ask you what I need to do here. Hey, I have confidence in Alan. He's gonna rock it.
He's gonna rock it.
He's not gonna rock it that hard. This is getting weird. Oh yeah. All right, Alan, rock this thing hardcore. What do I do? Okay, what do I do with them? Yes. You want me to go and just distribute? Now, what do I do? Well, that really isn't proportional, but whatever. It's tricky from here. We haven't really done one like this. What is the natural base here? Right. So we're going to swing it. Now, 10 to the log to the 10th, which you can put into the calculator. No problem. Well, somebody might be able to do this faster than me. Somebody punch into your calculator 10 raised to log to the 10th. Is it just 10? Neato. Yeah, if log of 10 finds out, yeah, that's true. That's true. If a log has a base of 10, anyway, yeah, so it's basically 10 to the first. Just punch it in the calculator. 10 to the log 10. I'll just do it now. Yeah, same way we did on the last slide. To get rid of the log, you bring the base, which this one has a natural base of 10, over, and this becomes an exponent. I just wrote in this. So you punch into your calculator 10. Where'd it go? I guess I hadn't done it yet. 10 to the log 10. Nope. Yep. All right. So 10, that's an 11. Raised to log of 10. Dadgummit. It's 10. So that's x squared plus 3x equals 10. Now what do I do, Alan? Close. But you can't. You're on the right track, but we want to solve it all together. So, Kim, there you go. Subtract the 10, then we can just use quadratic formula. So many voices. What? Let's see. You may be right. Negative 3 plus or minus b squared minus 4a. You make it a negative 10? Negative 10? So it'd be negative 3, 9 plus 40 is 49, square root of 49 is 7. Yeah, so it'd be negative 10 over 6, so negative 5/3, and positive 2/3 if you work it out. Negative b over 2. Yeah. I don't know where I got that 6. Yeah. Oh yeah, well that's what it was when I corrected the 6. Sorry, I don't know where I got that 6. Sorry, this is the 2. Okay. Questions. That's as hard as they get. I'll let you look at the other problems just to see if there's one on there that looks different. We're almost done. Then you can talk to your heart's content. Please look at 69 through 75. 73. The only reason that one looks different is because it's the first one with subtraction and 3 logs. So we're going to have to use division. You want to help me through it? No. Sure. Kim, you just want to write on you? Then I'll narrate what you're doing. Yeah, could be.
Hey, Coach, can we make fun of the birds? What? Can we make fun of the birds?
No. Give it. So, first thing she's doing, where the addition is, she's multiplying, and she went ahead and FOILed that out. Now, actually, it's just this part over. Now, where the subtraction is, she's dividing by x. Yeah. Well, whatever. Equals 2. Yes. Yes. Since they all have the same base, they can all go in the same log. Really, it's just this part that's over x. Can you erase this piece right here? No. Thank you. Whoa, not that. You can go here. It's not under the log. Over x. Okay, see? These two are multiplied. That one's divided. Now what do we do? What? We haven't done that part yet. That's what she's doing. No, this 2 is that 2. She hasn't done anything with that. All she's done is combined all the logs. Now she'll be swinging this 2 over, and it'll be all this equals, you're right, 2 squared. Because, when you get rid of a log, you bring the base over, and it becomes the base to this power. So that's how we got rid of the log. So keep going. Now she's multiplying the x to the other side. Then she just subtracts it over, and we're back to a quadratic, and it's just like the last two. Well, the ones with multiple x's, yeah, they're probably going to be multiple answers. But the ones, yeah. I think 2 should be as high as you go. I would think. I guess there's a chance you might have a 3 one, but I don't think so. Question. Sure. Once we get to here, then we need to get work from here. Quadratic formula. Can you write the quadratic factor? Nice. You like the factor. Yeah. Yeah, because there was addition, we multiplied them, because of subtraction, we divided it together. Well, we just did it all at once, but yeah. Really, it was x minus 6 times x minus 4 over x. No, that's what she chose to do. If you're a good factorer, yeah, go ahead. I mean, I'm not promising you're not going to have any fractional answers today, but there is that possibility. Thank you, Kim. Muchos awesomos. Hold on for just a second. Questions? No? Great, then we're done. And there's some review on here as usual. Just kidding, that's not the right slide. There we go.
You should change it to E.